In this video, we are going to go through the example where we will have to perform implicit differentiation with the problem where we have to work with cosines, sines, and so on. So first I need to read the problem. Find the slope of the tangent line. The slope of the tangent line means I just need to find the derivative, f prime, and then plug the points they gave me, in this case 7 pi and 3 pi over 2. 7 pi and 3 pi over 2. We don't need to actually find the equation of the tangent line, just the slope. That's our slope. Well, sounds easy, but we'll see how challenging this problem will be because the very first step requires implicit differentiation. How do I know? Can I find y explicitly so that we can find y prime right away? Not really. Look, I have cosine y multiplied by 4, then cosine y multiplied by negative 4 sine x, and so on. You can try to solve for y here, but it's much easier to use implicit differentiation since y is not given explicitly. I showed steps for the implicit differentiation before, so now I will just briefly mention them and move on. First step is to differentiate both sides, left-hand side and right-hand side, keeping in mind that x is an independent variable and y is a dependent variable and depends on x. So every time I will be differentiating any piece that involves y, y prime will pop out. 5 sine gives me 5 cosine x, but 4 cosine y gives me negative 4 sine y times y prime. Just like I told you, every term that includes y, when you differentiate this term, y prime will pop out due to chain rule. Move on. Next piece requires product rule. Let's have 4, let's not include negative sign. Let's have 4 sine x to be u, cosine y to be v, and start differentiating. Minus brackets. Derivative of 4 sine x is 4 cosine x, copy cosine y, plus copy 4 sine x, differentiate cosine y, negative sine y. Is that all, or we forgot something? You're right, times y prime. Do you see that plus 1, plus x over here? Don't forget, that will give you plus 1, and the right hand side is 7 pi. Since I have a questioned intonation, you might guess that I need to point out a very common mistake. When students get excited that they have finished differentiating left hand side, they forget to differentiate the right hand side. 7 pi prime gives you 0. And this is my equation. Step 2 tells you to identify all parts, or basically terms, that involve y prime and move them to the left hand side. This term is written on the left hand side, and this term is written on the left hand side, but don't forget to distribute negative sign. Everything else, move it to the right hand side. I will have a negative 4 sine y times y prime minus, is it minus though or plus? Let's carefully look at this. This negative sign and this negative sign gives you positive sign, so it becomes plus. Plus 4 sine x sine y times y prime equals everything else, move it to the right hand side. Let's start with whatever was on the left. 5 cosine x becomes negative 5 cosine x. This term over here was negative, so now it's going to be positive 4 cosine x cosine y, and finally minus 1. Now leave right hand side as it is. For a while we don't need it. Now our job is to identify y primes and factor them out. Basically, the whole process right now is to solve for y prime. I'm just carefully explaining steps to do that. But you can do it different ways. You can move everything to the right-hand side and left-hand side, vice versa. Factor out right away if you're good at that. Your choice. Y prime brackets -4 sine y plus 4 sine x sine y closed brackets. The right-hand side stays the same. You rewrite it. I'm going to copy it. Copy. Paste. Final step is to have y prime equals form. Y prime equals right hand side. I can even give you this notation. I like giving it in class. I usually say y prime will be right hand side over those brackets you have. But it doesn't work if you moved everything on the other side. You might choose different sides, whatever you want. So I will paste again the right hand side part all over the brackets part -4 sine y plus 4 sine x sine y. And this is the answer for y prime. This is not the final answer, just for you to know, but I wanted to point out that this is the most important part. I would say the most challenging part right now. And also, while I'm talking to you, I'm very fast checking my answer with the answer I have on my cheat sheet. Looks good. Okay, this was A, implicit differentiation. Do you remember what we were asked to do? We were actually asked to plug this data into derivative because we want to find slope of the tangent line. We just found a derivative. So I'm going to plug x equals 7 pi and y equals 3 pi over 2. That's going to be B. See, we had A, implicit differentiation, B, x equals 7 pi, y equals 3 pi over 2. Let's do it carefully. Let me put it like this. Y prime becomes a fraction, and I will have -5 cosine of, let me use purple color for x's, 7 pi over here, plus 4 cosine x, that's 7 pi, times cosine y, that's going to be pink. It looks kind of the same as purple. Let's use orange color. That's going to be 3 pi over 2 minus 1 all over minus 4 sine y, which is 3 pi over 2, plus 4 sine x. X is purple 7, 7 pi, not x. 7 pi. 7 pi. And finally, sine y, and y is 3 pi over 2, orange. Your job is to remember the unit circle. That's going to be very helpful right now if you remember it, because we don't really expect you to use calculator for this. At some point, you just have to remember what is happening in the unit circle for cosine and sine. So I will tell you what's the easiest part to remember. Sine at 0, this is how I like to explain it. Sine at 0 and sine at pi are what? 0, exactly. Because sine represents height, and at 0 and pi, the height is 0. So that's how we know sine here is 0. Sine here is 0. Then sine of 7 pi will be 0 too. Sine of 0, pi, 2 pi, 3 pi, 4 pi, 6 pi, it doesn't matter. So sine of 7 pi is 0. That means I can take red color and say that all this piece over here is 0. Do you see any other sign of 7 pi? Unfortunately, there is no others, so we will have to struggle with other cases. Then I remember this thing. So what about cosine? Where cosine is 0, maybe we're lucky to have one more 0 piece, but due to cosine, I remember that cosine is 0 at pi over 2, right? Over here, because cosine is my length. What's the length at pi over 2 is 0. And also at 3 pi over 2. 3 pi over 2. Cosine is 0. Cosine equals to 0. Then, do you see that part somewhere? I see it over here. All this term, not -1 though. Let me go up. Is 0 as well. Don't include -1 into this story, it's not 0. Now we just need to figure out the other two angles, cosine of 7 pi and sine of 3 pi over 2. Okay, sine of pi over 2 over here, since it's height, that's 1. Sine here is 1. 3 pi over 2 is over here, and height here is -1. So this piece over here is -1. Cosine of 7 pi, what is that? Well, cosine of 0 is 1. Cosine of pi is -1. Then it means that cosine of 2 pi is 1, 3 pi is -1, 4 pi is 1, and so on. So at odd numbers, it will be -1. So this whole thing is -1 as well. Let's write down what do we have, because it looks kind of messy. -5, that was in front. Cosine of 7 pi is -1, plus 0 minus 1. -4, that was in front. Sine of 3 pi over 2 gave me -1 plus 0, which becomes 5 minus 1 all over +4. 4 over 4 is 1. The slope of the tangent line to this complicated function here, which was not even shown explicitly, at 7 pi, 3 pi over 2 is just 1. That's a very nice simple answer. This is a good example where you need to, first of all, be very careful with trigonometric functions, product rules, collecting all the terms together. Don't mess up any negative signs. And then at the end, when you plug your inputs, and as you can see, we give you both x and y, because when you use implicit differentiation, your answer includes most of the time both x and y. When you plug those values, you should be careful, and hopefully you remember trigonometric functions at different angles to get the right result faster. Thank you.